All right. I added a link here to some JavaScript stuff. And so that's for you to look through. Maybe when I meet with students to talk about JavaScript, I'll probably ask these questions. And so what I wanted to do today is talk about JavaScript and also the canvas element, if I can get to it. And let's see, I will do the following. Let me I'll make a folder. So here's a web page. I want to talk about JavaScript a bit in the beginning here. Just to see if we're all set up, I'm going to just print OK to the console. Forgot where it was. And this will be canvas. Oh, sorry, I'm in here. I'll open up the JavaScript console. There's the OK. And I wanted to talk about prototypes. So JavaScript doesn't use classes like you would see them in C# or C++. It's got this thing called Prototypal Inheritance, and it works a lot differently from those non-scripting compiled languages like C++. So I'll start with just to show some how things work a little bit. So you can create an object. I'm going to use O for the variable. And there we go. We create an object just like that. And that's the same as doing this. And I think it's also the same as doing this. You know, JavaScript has a new operator. And I don't know exactly how useful it is. I mean, people try to use it, and they try to make JavaScript look like, you know, like Java. And but my feeling at this point, and I spent a lot of time trying to get working out different types of patterns. And what I prefer is to just use the prototyping and just use it directly rather than trying to design classes in this language that is not originally designed to support classes. So I'll show you a little bit about how to do that. So here we create this object O, and we can add functions to it like this. We can do the O dot, say, if we have a hello function, so it's O dot hello equals function, and you know, we could do console dot log. Well, let's not do it like that. Let's return hello. How about that? So if we print O dot hello, it should return hello. Just let me do it like this. I'll change this. I'll call that just call it F. That's a function F. And that function returns a string hello. Or better, I'll do it like this. I'm F. There we go. So we're going to print I'm F here. There it is, I'm F. Instead of checking to see I'm printing that, another way to do these tests would be like this. Console.log, not log, sorry, console.assert O.f, and that's a call, that equals I'm F. So this is an assertion. So if I say I'm G, that's a failed assertion. Let's see what that would look like. I'm going to clear the console window and reload. Assertion failed. Line 9 right here in index.html. This is line 9 right there. So this assertion has failed. And this assertion, this is, we're passing it, we're using one argument here. We could pass in a second argument and customize the message. I'm not G, right? So I'll clear this, reload. I'm not G. So we can put our own error message if we want. So this is a good way to write tests. I'll just leave it like this. It's easier for me. Just this will fail. If I go I'm F, this should succeed. Wait a minute. There we go. Notice I'm using this triple thing here. Watch this. I want to explain that. If we return 3 from the function, and then we should get 3 as a result. We call the function. So that assertion is okay. And test that. Looks good. But if we compared F to, say, the string 3, you know, the number 3 is not the same as the string 3. So that assertion should fail. And there it does. Line 9. I go to line 9, there it is. This assertion fails. But if I take one of these equal signs out, now it succeeds. No problem. See, this equality here tries to do type conversion. If the left-hand side and the right-hand side are of different types, this equality operator will try to convert those types into the same type and then see if they represent the same thing after that conversion. And if we try to convert the string 3 to the number 3, well, yeah, we'll get a number 3. So the equality is good. If we try to convert the number 3 to the string 3, well, that's easy to do, and yeah, equality would hold. So 3 equals, the number 3 equals the string 3, allowing for type conversion to take place, automatic type conversion. But if we use 3 equal signs there, we're saying don't do the type conversion. If they're not the same type, return false. We don't want equality if they're different types. So this is a strict equality, a stricter type of equality. Assertion failed. Just to show you how that works. Now, let's make another object. I'm going to call it O2. I'll call this one O1. We'll just wait on this. We'll figure out what to put in there in a minute. So we can do something similar. We can create this O2, and we can give it the same function. We could do O2, maybe we want O2 to have the function f, but we also want another function g, say. So we have O2 is going to have the function g, and this returns 9. And, that's just O2.g should equal 9. That's good. But if we try to call f on O2, and we want it to compare to 3, of course. Well, f is not defined for O2, so we should get an error message for that. O2.f is not a function. It's undefined. In fact, if I, down here, I could do, what is it, O2.f. Undefined. But we can add f to O2. That's a process called mixing in. We can use a mix-in process. We could say, well, we want O2 to have that f function as well. So we just take the function in O1 and assign it to f in O2. You see this f, right? Think about what that is. This f here, that O1.f, that's a pointer to a function. So this assignment is assigning one pointer to another pointer. So this f here, that's a variable, an attribute. It contains a pointer or a reference. We'll call it a reference, right? We can use the word pointer if we like. It's a reference. It's not the function itself. It contains a way to get to the function. So that's what we're setting that variable equal to. So now O2 should now have this function f, and it should return 3. And there it goes. So this is what mix-ins do. They'll take functions from one object and just copy them into the other object. And I think that's a great way to do it. I think that's simple, it's easy to understand. There's another way to do this. And we could do this. we can take O1.f and see this O1.f, remember that's a pointer to a function. And a function is an object, just like anything, like this O1 is an object. This f is we're setting f equal to this function, but that's a function object. It's just another object. Everything's an object. Well, this 9 is not an object. That's a primitive data type. So they do have some separation. So this O1.f is a function, and what we can do is we can call it and use O2 as what's called the this variable. And it's not, you know what, I'm getting off on a tangent here, but just to show you that this would actually work. Yeah, that's okay, but I don't want to get into that. So this calling is very important here. So this, but I can explain that a little bit later. This doesn't fit in right now. So this would be f. So right now, the way we have it, O2 has a G, but no F. So this is undefined. Oh, that's O1. See, it's good to be testing all the time because it catches little bugs. So let's look at another way. We're going to use prototyping in order to add F to O2. And the way we can do that is like this, where we create, see where we create the O2 here? Instead of just assigning it, you know, that object, we're gonna, this is a pre-existing class or pre-existing object in JavaScript called object. It's like the parent of all the objects. You think of the objects as forming a graph. And so it has a create method. And that's the same as what I just showed you here. This is just returning this generic object. But this create method takes an argument optionally. And I'm passing O1, we're saying create this O2, but make it use O1 as a prototype. Kind of like inherit the functions and all the attributes of O1 actually. So make all the attributes of O1 look as if they appear as attributes of O2. So if we create it like this, now this assertion will succeed because the system will find F in O2 because O1 is set as O2's prototype. There's the test. And, you know, what does that mean? You know, what does it look like? Actually, there's a field in there. In O2, let's see, O2 is the object. There's a field in here, it's this proto. It's called proto. In the past, you weren't able to access this attribute directly. It was hidden, it was not allowed. It was like private and hidden. But these days, more JavaScript environments allow direct access and manipulation of this field. And this is, in fact, I'm going to use assertion here. In fact, this O2 dot underscore underscore proto underscore underscore, that in fact equals O1. So O1 was set as the prototype when we created O2. So this assertion should succeed. Let's check it. Good. There's another very confusing, and I don't know if I want to get into this today, because it'll just confuse everybody. It's like the language was designed deliberately to be confusing to people. There's another field called, prototypes, or console, assert. I'll talk a little bit about that because you'll come across it in your readings. And you'll need to understand it. And I could get into it more later. So if I do O1 dot prototype, this should fail. This should be, I think that's undefined. I better go. Let's see. I believe that's undefined. So this O1 does not have something called let's be clear here. O1 has got this underscore prototype business going on. So that is not undefined. So O1 has this prototype pointing to its prototype, which is given, by the way, it's given by the system. It's some sort of parent prototype. It's the root of this prototype chain. And so that's defined, but this O1 doesn't have a prototype field. So let's see if that holds those assertions. Yeah. And let's look at the function f. So O1 has a function named f. Now, that's an object, right? Just like any object. It just happens to be a function, but it's considered an object. And all objects have this prototype field. Underscore prototype. Not this one, unfortunately. So this is not undefined. In other words, it is defined. But this one down here is also not undefined. It's also defined. Because all functions are assigned an attribute named prototype, because all functions can serve as arguments to the new operator. And when the new operator creates an object from a function, it attaches the value of the function's prototype field as the underscore proto underscore attribute of the created object. It's very confusing. And it's not necessary to use the new operator. I don't think the new operator is that useful in Java. I think it's a source of confusion. All right, let's take a look here. There we go. Functions will have a prototype field, but that field, keep in mind, is not the function's prototype. An object's prototype, including functions, is named underscore proto underscore. This is very confusing. This is the function's prototype. That's a reference. Every object has a prototype. And when I say every reference has a prototype, I mean underscore proto underscore. That only functions have a prototype field. Well, you could put a prototype field on something that's not a function. But when you create a function, it's automatically given this prototype field, because the function could be used with the new operator to create new objects. And don't want to get into that too much more right now. I'm just going to take that out and take that one out. And we'll just not use the new operator for the time being. But this is very useful here. to use this create method and to produce an object with this O1 prototype. Now, there's another way to do this. Suppose we create O2 in this way. That means that O2 will no longer have F, so this should fail. So we're not setting O1 as a prototype for O2 anymore. We're just creating O2 using this alternative syntax, which uses this like terminal prototype that's comes with every object. So F, this should fail. This is, F doesn't exist. That's what it will say, something like that. F is not a function. So, so in other words, it's not a function because it's not coming down to the prototype. We didn't mix it in by adding the F to O2. It's not coming down from O1 because O1 is not set as a prototype. So F is simply not there. But let's add it in another way. Let's just take O2 and assign it directly to that prototype. There it is, O1. We're going to assign this directly. Now this never used to be possible. This was not allowed, and they would force you to create a prototype like this using this syntax. But then they loosened up the rules, their implementations. They didn't follow that restriction anymore. They started allowing access to this field directly. I think I can do that. Let me check. So now, instead of failing, F will be found because, O2 has O1 as a prototype, and F is defined in O1. So let's see if that holds. Should be no error message. There it is. So, these two lines right here, we create the O2, and then we set its prototype field to O1. That means all the functions in O1 automatically become functions of O2. These two lines are equivalent to this one line. This one line does the same thing as these two lines, and with the same effect. So we'll just take those out for now. Now watch this. So we know that this runs, F returns 3. And O2, now you can override these inherited, I say inherited through the prototype chain. It's a chain, I'll explain that in a second as well. We can overwrite the function in a sense. Let's return 99. That's not, it's not 3. Oh, no, it's, sure, 99 is all right. So now this should fail because, and notice, see, O2 has an F that it got through its prototype. But if we define F directly on the object itself, the system, the JavaScript engine, will use this function here. It won't bother to go up to the prototype and find the F there. So when you go O2.F, it's in this expression here. You think about the engine, the JavaScript engine that's making everything work. It looks at it and says O2.F. Oh, okay, I got to find and run function F. So I look inside O2 and I find it. I said, well, there it is. Run it, and it returns 99. Now, if these 3 lines are missing, and we got to this point, the engine would get here and say, oh, we got to run function F on O2. it looks inside O2 and it says, well, there's no F. Oh, well, let me check the prototype. And they check the prototype. Oh, the F is in the prototype. That's the function we're going to call it on there. We'll call that F. And if it doesn't find it in the prototype, well, the prototype is an object, and all objects are prototypes. So it goes to the prototype's prototype. If it's not there, it goes to the prototype's prototype. It should go, that's the chain. So it'll go up the chain until it hits the end of the chain. And then it stops searching. And then it'll say F does not exist. Now look at this. So we can override it here. We don't want the search to go up the prototype chain. We want to define F as returning 99 directly in O2. So this should fail. There's the failure. This is now 99. So that's all I want to talk about today about, yeah, question.
If you run that const O2 equals object.create line twice in a row,
This one up here?
Yeah. Does it overwrite at the same address, or does it create information at two different spaces in memory?
This here?
Yeah.
Let me tell you what happens. Okay, this line here, this creates a new object and assigns it to the variable O2, right? And this line creates another new object and assigns the new reference to the new object, different pointer. It assigns it to O2, overwriting the pointer that was assigned from the first creation step, right? So that means this object here that was created in this line is now unreferenced. It's like a memory leak. So we lost the reference to this object. It's out there, but we can't get to it anymore because we didn't store a reference to that object.
Okay, so if you did that and put each one in an array.
Well, then they would both exist.
So you can just skip new.
Yeah, you could do this. Now both objects exist inside this array. And we'll call that, we'll just call it A for array. And now this would be, A of 0. Watch this. Yeah, this is fun. Let's do this. Here's the question. Okay. Obviously, this one is A0, right? And this one produces A1. So here's the question. And this is a question for everyone. If we do A0 and we compare it to A1, is it true or is it false? Is it true or false? Anybody want to guess? I got to guess, right? Because I'm the professor. But I got to give the last guess. Because everyone's just going to say what I say. Although I'm not always right. What is it? True or false? False. They're separate objects, right? Two different pointers, the objects are identical in all ways. It's like having a twin, sibling. That's my brother, looks exactly like me. You can't tell the difference when you look at us. But we're actually two different things. Okay, so this will this assertion will fail. These are different objects. Now, I'll show you something that's kind of like if I put in a string here, remember that failed, right? What we just saw failed. Now, strings are also objects. These should be different, right? That should fail too. Well, it doesn't. Because I think what happens is the engine, it doesn't make two strings and create two different pointers. It says, oh, we already got a DDD. So, and strings are immutable. I better check that. Strings are immutable. They cannot change. They're the only immutable values built into JavaScript. They're not the only ones, sorry. Numbers are also immutable. So it created DDD, and then when we want to use it again, it's like, well, I'm not going to recreate. You see, here it only creates one version of the string, but when we created two identical objects, it makes them separate. It considers them separate, but even though they're identical. So this should succeed, whereas the objects failed. That succeeds. These are, in fact, equal. If we did this, they will fail, even though they're identical. Those are identical empty objects. Failure. See, these objects are mutable. So I could do something like this. I could do a of 0. I could add an x. See, because they're mutable. But I can't change a string. You cannot change. You know, DDD, I cannot do this. I cannot do DDD dot, change. I can't change it. There's no function for me to modify that string. I can't, I guess, add an x to it. Can I do that? I don't think I can add an x to that. It's immutable. Let's see if it, gives an error. It's going to give an error message on that. Don't need this. No error message? Okay. Isn't that weird? It add that to 7? Hold on there. Can I do this? Is that going to print 7? So immutable means that the characters can't change, but I can attach attributes to it. Yeah, I never thought about that. I wonder if you could make use of that. Let's see. Will that print 7? This is guessing, right? Well, I'm just guessing up here now. I think it's going to print 7. Undefined. So, what the heck? It allows this, and it doesn't, you can't turn around and use it. Okay. So Anyway, it's weird, right? I don't know what this means anyway. So, well, I do know what it means. I could think of what it could mean, but apparently this is not a technique that we can use in our code. All right, what are we going to do now? Any other questions about prototypes? Yeah.
How do you work with that and keep it readable?
How do you work with what?
How do you work with all that and keep it readable? Because
Oh yeah, keeping it readable is the secret. Okay, definitely. I mean, I can show you as we go forward. I mean, I'll do my best to keep it readable, and you got to figure out on your own there how to keep it readable as well. Um, so yeah, I'm constantly working on readability, always trying to improve it. It does get messy. You know, what people say about JavaScript is say, well, you can't write a large system with a scripting language. You need to have strict data typing. You know, you need C++ or Java or C# to write a large system. And when you use a scripting language like Python or JavaScript, when you use one of those languages, it tends to get messy and hard to maintain when it gets large. That's the general opinion that I've come across. So something like it's faster to code in script. You can bang it out real fast and experiment easily. But when things get large and complex, it's easy to make your code messy. Now, that's the opinion of others, and I do feel that that's true. So you have to exert more. You have to have more self-discipline when you're coding in a scripting language to keep your readability level up. So you just have to spend that extra time and energy to maintain that readability because the language is not enforcing it on you. Okay, as well as other languages. Yeah.
If you created an object O3 with the prototype of O2, would
Yeah.
it also have all the functions of O1?
Yeah, if I create an O2, is this the question? Like with this create method?
Yeah, and then you make an object of O3, would it have the functions of O1 as well?
Let's try it. We're going to create an O3 because we have this idea of a chain, right? Look at that. So the prototype of O2 is O1, and the prototype of O3 is O2. So not log. So we have O3. Well, let's print. Let's go ahead and print it. It's easier to think about sometimes. So O3.f. We're wondering, does this even work? Is this going to print 3, or is it going to say f is undefined? What do you think? It's going to print 3. Yeah. So that's why they call it a chain, a prototype chain. There's the 3 right there. Yeah, you can get long chains. So this is a way to, maybe you have, yeah, I don't want to get into that, but yeah, I mean, multiple inheritance, you can't do this way. This is a single inheritance chain. So if you want to do multiple inheritance, then you got to do the mix-in approach, right? So you could do, maybe there's, then you would use a mix-in approach, and which would be like this. So you'd have O3.f equals O1.f, and then maybe O3.g equals, x.g. Maybe they get it from somewhere else. And so I can't inherit from O1 and x, but I can mix them in just by adding references to the functions. So this is called a mix-in approach. Then you don't need this creation anymore. Then you just do this. Watch. Just And this might be easier to think about. So you just do O2 dot F is the F of O1. And this is what it would look like as a mix-in. And this, so I can do O3 dot F equals O1 dot F, or I can do O3 dot F as O2 dot F, which is, you see this, the difference? There's no difference, because this F here, O1 dot F is a pointer, is a variable, and this O2 dot F, that's another variable. These two variables contain the same pointer. So I'm just getting the pointer from this variable, or I'm getting the pointer from this other variable. They're the same variable. They're the same pointer value. They're the same value. So how do you want it to look? Do you want it to look like this, or do you want it to look like this? But this is the mix-in. We're not using prototypes here. I think the trend is more toward mix-ins now. And that's what I see happening with the JavaScript developers. The crackerjack JavaScript programmers that write outstanding articles on like that site. Anyway, I won't get into that. I see more reliance on mix-ins and less reliance on using a new operator with prototyping. It's more flexible. All right, what about, any other questions on this stuff? I mean, we can keep going on this. Yeah.
Using create like that, can you pass additional functions in like you would new on for a constructor, or do you have to do it after the fact?
To pass in new functions?
Well, let's say you want to pass some parameters into your object on creation, like with a constructor.
Oh, yeah. You can use a factory method. If you're using mix-ins, then you're going to use it like a factory method to create objects normally. Because you don't want to do this manually all the time. So you call your factory method, attaches the functions that you want. And the factory method will take those arguments that the constructor would take.
Okay, so you kind of like do it like this, build it all into a function, and then just call it function.
Now let me show you how. Let's suppose we have a function where we want to create O2s. Okay. I'm going to call it a function. I'll call it create an O2. So we didn't define O2. We just have a factory method here. So we're going to do, we'll call it O, and we create the new function, the new object, and then we want F to be the F from O1. And then we return this object. So now we create an O2 like this. And now we have the O2. I'm getting to your point there. I'll show you the arguments in a second. So this should be good. There's the 3 there. And so this would be called a factory method, where it's like a constructor. So you're creating a new object in here, initializing it, and then returning it. So that we call the factory method. It's like calling a constructor, and it returns this O2. Or whatever you want to call it. You call it P, whatever you want to call it. And But if you want to pass in an argument, let's suppose it's XY coordinates. So you're going to pass that in. So you could do something like this. Now when we create O2, we got to pass in, 3, 11. Those are the coordinates. So now we're going to have, we print X and Y. There it is, 3 and 11. So that's a way to, just like a constructor, you could pass your arguments in and then just set them in here as it's like member variables, member attributes. What is this? Oh, it's 01. Do you want to see how to use the new operator? We could do that. Yeah, you don't need to. I mean, because it's, and this is typical of a scripting language. There's many different ways of doing something, but in Java, there's not many different. You just got to do it that way, right? That one way. So there's a lot of interesting flexibility that you get. So then it's usually as you're coding and you're doing it one way, you're following a pattern, and then you start following a different pattern, or maybe copy some code from somewhere, paste it in, and it's using not your pattern, but a different pattern. And then you're starting to have different ways of doing the same thing, and then that's when things get a little messy. So you have to sort of practice discipline. Say, if I bring new code in, I have to rewrite it so it fits within the style of the existing code. Just for completeness, I'll show you how to do it with new. So here, well, no, I don't want to do it. It'll create confusion. Later. I'll do that later. I wanted, with a moment that we have here, I wanted to, well, do we want to keep on this? This is an important topic. I'll move too fast. I wanted to talk about the canvas, because there's a number of you that are working on games. So I wanted to kind of shift into game programming a little bit. And all this is going to come up. This is, you're going to be using this left and right, as you're coding, this stuff right here. This will be all over the place when you're doing a game. So for the game, you can do different kinds of games. Like if you have a point and click game, you could use DOM and just, make rectangles appear and disappear and images move around in the web page. So you can do that. But if you want something that where you need smooth animations and you need more flexibility, something like a space shooter game, maybe you have moving bullets, projectiles, and you need to be responsive and quick to the user input, then you need to use Canvas with this request animation frame function. I was going to start talking about that. Should we dive into that now, or should we call it a day? Let's wait. But what I'll do is let me introduce you to some of the code that I've got here. Let's see, what did I call it? I think it was game 2. Just got it working. Just got it working when I sat down today here. It's not a lot to look at. Just get rid of that. That's all it is. Just a.js and index.html. So here's the HTML. See this star? So it matches everything. So put a red border around everything for debugging. This is what people normally do now. Just set margin padding to 0 in the body element. It's like it's just sort of just to clear that out. And here is the rule for canvas. So the canvas, I want it stretched to 100% of the available screen space in both directions. And so here we define the canvas here, and then we load that script a.js. So A is like short for application. I just wanted to keep it short because we're going to use that letter a lot. So first we load this a.js, so that loads and runs. And then after a.js runs, well, it's going to define an object called A. And inside that object is going to be an array of objects, objs. We're going to push onto that array of objects some text to render on the screen. This is a game object. A.text is a game object. And it'll be at this position 100, 100. So there's the high right there. And notice how what I wanted to do was, and this is something I'm figuring out now. I want see how the canvas adjusts when you get larger and smaller. So I want to make a game that where the canvas fills the entire screen, and it doesn't matter what size you set the screen at. That's what you have. The canvas is in the screen, and you can resize it. Oops. So here's that a.js file here. Here we create that A object. See this here? Window. Why do I do window.a? Remember, Windows represents the global namespace. I mean, it represents the window object. You know, your window. And but also all the Windows attributes are considered the global namespace. So we want to make A available globally so we can reference it wherever we are. You see here, this script here, we just said a.obj. Well, A is global. We didn't have to write window.a. Well, we could. It's the same A. Okay? It's the same A, we get the same result. And the other thing is, this is optional too. I just do A equals that. A goes into the global namespace. That means A becomes an attribute of the window object. It's the same thing. There it is, the same behavior. The thing is, people will write it like this. It's just like a documentation. It's saying like A is global. Like I said, well, where's A defined? Normally you would see something like this, you know, maybe down here, buried in some code. And, you know, if you just saw this, you'd have to wonder, well, A is, you know, are we in the global namespace, or, you know, so we don't know our context. So we'd have to think for a minute, well, what's our context? Is A local to something, or is it global? You see that extra thinking you have to do when you see this? But if you write it like, whoops. If you write it like this, you don't have to do that thinking. You say, oh, A is global and it's a new object. Go, done, and move on. See when that's the kind of coding you want to do. Is make it more readable, so you don't have to think. Well, is A locally scoped, or now you don't even have to think about it. I don't know if you understand that point, but that's a readability issue. And once A is defined. See, so I put A in the global. That's the only thing I made global, is A. So the application, if it needs to get something, it goes through A. So one thing we do, so we start populating. It's like we have our own namespace. It's the attributes of A. So we start to populate it with information. So we've got an attribute called canvas. We use that getElementById function to get the canvas. See? There's the canvas here as an ID. I just call it the ID canvas. Yeah, there's another way to do this. You could do getElementByTagNames. You know, you could do it like this. Now remember, there's so many different ways of doing things. Now I don't need an ID. You know, I get the getElementsByTagNames. I know there's only one in there. That's a canvas, and it'll have to be the first one. So there's an alternative, and then we don't need this. Then we don't need the ID. Oh, that's nice not to have to put the ID in there. Oh, something's wrong. Oh, that's because up here, see. That's one thing that's wrong. And there's another thing that's wrong as well. I don't want to get too much into that. But this will work. It doesn't work. Get elements, I think it's get elements by tag name. Sorry, I spelled it wrong here. Yeah, there it is, sorry. So I had an error in the JavaScript. But this get element by ID was one of the first DOM methods that worked everywhere. It was very reliable. It could always call it and get it to work. This one wasn't supported by some browsers, but now all browsers support this, so it doesn't really matter. So you pick your style, what you want to do. And skip this line for now. Here's the CTX is short for context. You see in the documentation and articles online, they use CTX a lot for the context, the canvas context. So the canvas object has a getContext function. And there's a number of different contexts that you can get. There's the WebGL context to do 3D animation using OpenGL. Or you get this 2D context where you do 2D animation. So let's start with the 2D context. Then I'm adding an OBJs array. That's to store game objects. So we're going to have a lot of things going on in the canvas, see? And they all have their own update methods. So you've got something going this way and something else going that way and a bullet going this way. And each one of these are like independent game objects. And they all have these update methods and draw methods. And you've got a frame rate. Remember, 60 times a second, you're going through your loop, and you're going to call update and draw on every game object that's visible or that has some effect on the game. So you got a loop that runs through your game objects, calls update on everything. And it runs through your game object, calls draw on everything, like that. So this is the array to store all those game objects. And then keeping track of time is important. When you do animation, you want things to move at certain speeds. You've got to keep track of the time. So I was setting time to 0, and I make sure time is in seconds. This is that represents duration into the game, not the time of the day, but the duration. When the game started, it's time 0. And here's a frames per second variable. And I'm just going to initialize it to 60. That's about what I get now, my system here, 60 frames per second. And this will modify up or down depending on the frame rate. This is the main loop. This is a window resize function. This is for adjusting the canvas when the user stretches, changes the size of the window. This is that request animation frame function that's critical to making this work. And we can go through this code more next time. This is a mouse down event listener. I don't have that prototyped here, and this we could add to that. We're running out of time, so we won't do that. And then like what we were talking about today, the prototypes. So I created a container. Well, it's just an object, right? All objects are like dictionaries, name value pair dictionaries. So I created this object called protos under A, and this will store the prototypes that I use when I create objects in the system, game objects. So the first prototype is just named O. O, that's for the top. That's the parent game object, and everything else is going to sort of inherit from O. And O has 4 methods: update, draw, mouse down, and key down. So update is a function that takes a delta time, dt. And notice I'm just giving it an empty implementation. It doesn't do anything. Same with draw. Draw doesn't take any argument, and I have this, the default implementation does nothing. And a mouse down takes an x and y coordinate. We want to know where the mouse got clicked in the canvas. And I'm just returning false that the XY that gets passed in is, does this mouse down event, is it clicking me? And I return false. No, it missed me. It's not clicking me. And then key down is also like, okay, you go through all your game objects and you say, hey, the user just hit the W key. I don't know what to do with the W key. I'm just a high-level AI guy. Some game object's going to consume that event, that information. So I run through the game objects and say, you know, I call their key down functions. I passed in the W key here, and most of them are say they return false. Like false means I don't care about that. But the one game object is going to consume it. Is the one is maybe the player object, and W means move forward. You know, like in a first-person shooter game. And so that player object is going to consume that event, that key down event. So it's informed of the key down, and it consumes it by returning true. So once the system gets true back, it's going to say, oh, someone took it and responded to it. I'm only going to let one game object sort of consume those key down events. So I don't call any others. So this defines this O object, and this object is going to be used as a sort of a parent. So all game objects must support these 4 functions. So all game objects will inherit from O through its chain, because every game object will have its update method called. And if you have a game object that doesn't care about update, well then its inherited update does nothing. So the purpose of inheriting these functions is to give everything a default that does nothing, so that the code runs without crashing. And then here's another, the name isn't that great. This is going to be for text. Here's another object, another prototype object, T. This object has O as its prototype. And then there's this thing called constructors, and this is not really needed actually. It's kind of optional, and I'll just leave that out. But T has this, now T inherits update, draw, mouse down, and key down, right? But all we care about for this text draw is just the draw method. So we're not going to use update, mouse down, key down. We're not going to bother with that. We're just going to override or implement this draw method. So now the inherited draw method won't be invoked anymore, but this draw method will be on T objects. Objects that have T as their direct prototype. And this draw object, well, it should have a text field, which is the text to draw, a location, X and Y in the canvas, and then some font. What font, you know? If you don't give me a font, then use this. If you don't give me a Y value, then use this. If you don't give me an X value, use it. If I don't find a text value, use an empty string, so on. So I could explain more about that later. And then once these, so I just sort of extract these text, X, Y, font, and then I use them to do the drawing. So the context object, we set the font, and then we call fill text, and that actually renders this text in that font at this coordinate XY. So that's what's going on with that high. This is the beginning of the game code we're going to start, playing with and looking at, just to get you started on this. And if anyone wants to look at this, I will put it in the repository. There it is. So if anyone wants to look at it, there it is. I'll continue with that on Wednesday. That's it.